My name is David Stone. I'm an integrated construction manager with Morrison Construction. What we're showing you today is our plan room computer, which we use to interface with our construction team. This is a way for us to get the information from the office to the field. We have setups like this in the field as well, and also our engineers that are in the field also have tablets that have the same or similar interface to this where they can access the information. The idea with this setup is that we have two touch screens that enable you to actually interact with it as naturally as you can expect on a computer without having to think about how you reach the information. And that's part of our interface here that you see is really gives you the ability to not have to think about how to get to the information. It's icon based, very much like an iPhone or an iPad, and you can reach that information. So with that said, one of the things that I wanted to show you is the enclosure model. So when I click on this, what it does, it basically pops up our model on the right here. And this is a model that is after we took all the design models and we basically shared this with our subcontractors. They took that and created a shop drawing that's essentially the end result of it is what you see here. So the end result, what you see here is really a shop drawing in 3D. So if I fly in here, this, by the way, this is the court building in the forefront here, and this is the office side of the building in the background. It's a 5-story building and a 13-story building on the back. And so if we fly in here, you'll see the level of detail that we get to in the model. One of the things that so you'll see there's the stairs in there. We are very concerned with how we're going to build everything. So our curtain wall sub will actually model all their embeds. We will actually show our embeds in the concrete, understand how the curtain wall fits in the picture, as well as if we go over here, you'll see the precast as well. So all the elements you see in kind of cyan or kind of purple are the precast elements, and basically when we started this process, we'd have weekly meetings to coordinate these issues and find where we have gaps in the design process. One of the things that our team likes the most, I think, is really the ability to access the drawings. So we have an interface just for our team to actually reach the most current design documents. So if I just go into one of our interfaces here, what we've done is we've linked all the drawings through a Excel file, which we create a HTML of, and then we have links to each of the drawings. So if I go to one of the drawings here, it'll open up over here. And the idea, these are touch screens, so you can zoom in and see the actual details. And also we have the actual details in the drawings hyperlinked to the detail sheet. So this is detail 2 on 3100. So I can go over here and find that this is detail 2 right here. The other thing that we do is we have links. What you see with these symbols here is basically our RFIs, which popped up on the other screen here. And so anybody can go and see what the status of that issue is. And so this is also available in our field. We have a field pod that includes all this information. The nice thing about this is that we also, kind of like a actual post-it set that you'd have, we also have the history of all the different versions of this. So I can go back and see what the history and what changed and why. And so I can know when this was last changed and understand the differences. So this is as far as the drawings go. And then we can go to, we have a lot of information about health and safety, audits, orientation. We also have the schedule So we have schedules for the two different buildings because we have the office side and the court side. And then we have the quality side of it. So these our engineers can take their tablets in the field and do their quality reports and checklists. We also have our 4D simulation, which we did the implosion of the existing building on here. And we also make it bigger here. And this is basically, see if we can drag it, just a Google Earth image of our site and the existing buildings that were here originally, to just this building and the History Museum. And there's basically this is a 4D movie of it. We show how we demoed the existing, and there's a little clip in here that will show you the actual demolition. So we'll go through that. We also have a live model of it if we want to. We can go through that, and that enables us to look at the different scenarios, especially when we're building the building getting out of the ground. This is the image of the demolition that happened August 15, 2010. And so, obviously, this is a movie, so we can see whatever sequence of it that we want to see. So just fast forward. This is probably about where we are right now on the project. We're almost complete with the enclosure, the larger elements of the enclosure. So, and if we go backwards to the main, we have access to submittals. We have our coordination models for each level. So this is where we store all our MEP coordination models. We also have interior coordination because we also have our drywall modeling and our millwork modeling. We can try and open one of those models. And while that's doing that, we can go back to something else. We have virtual mock-ups. Virtual mock-ups, here's an example of one. We did a physical mock-up. So before we did the physical mock-up, we actually did a sequencing of it in SketchUp to understand how we're going to build it. And figure out all the embeds and all the issues that we might encounter in the field, and sequencing in this video here. So this is a model of one of the courtrooms on the first floor of the courts building. And what you see here is mostly the millwork model right now, and also what you see above here is the coffered ceiling. It has light boxes in it, and a lot of it we had to do a lot of coordination to coordinate that with our MEP systems. And so the nice thing on our project is that we have the drywallers modeling all the framing, so we understand what the limitations are and what we need to work around. So this is a Navisworks model of the composite, and this is specifically for the interior coordination side of it. So, and then we also do virtual mock-ups of different areas, depending on where we think there's an area of concern of where we need to focus on. A lot of these are just SketchUp models that we did, and focus on what areas we need to improve, or what areas we need to review with the design team, and how do we want to implement the actual design details in the field. So that's what the SketchUp model affords us. Instead of building many different physical mock-ups, this enables us to review this with the team beforehand. That's probably going to open in the background in a second. Then the other part of it that we rely on a lot is our we self-perform concrete on our projects. So all our and this is just going back to the SketchUp model. This is a curtain wall here. Let's see if we can get it. And just what we do is we save different scenes to walk through the sequencing of how we're going to place the work. So this happens to be the office side entrance.
Yeah, water on these days?
and basically just walking through each element, understanding how we're going to enclose it, and what sub is going to be in what sequence, and helping to organize the work. So just going back to our lift drawing process, lift drawings are basically generated from a model. We take the model that we get from the design team, and then we basically we insert all the knowledge from our superintendent and our field team, as well as any shop drawings that we need to create. And we basically create a model that then we can use for that purpose. And from that we create the 2D 2D representation that our guys take in the field to actually build the project. Let me see so this happens to be our core right here. It's about 200 feet tall. We separate it into 3 sections. I'll open one of them and it'll pop up on the other screen. And the idea of the 2 screens too is so you can have multiple drawings up at the same time. Maybe in this scenario is maybe not the best example, but the idea is that you could have a structural drawing and mechanical on the other side if you needed to compare the two. So this is one of 16 drawings or 16 sheets that we give to our foremen in the field to actually implement the work. And that includes all the information they need, every detail, every insert, every embed, every opening, everything they need to implement this. So it takes all the design information, all the shop drawings, all the MEP coordination, and puts it in one set of drawings. So it includes all the embeds and schedules here. So this is the only thing that our foreman takes to actually build the project. So he can just take a printout of just this, and he can actually print it out directly from here, or he can take it in the field to our pod and print it from there and have it with him at any time.
So David, using this kind of technology, I assume that this has probably saved you a lot of paper, having to print large, stacks of drawings and so forth. How has this technology improved the efficiency and the kind of reduction of paper on a project like this?
I will tell you that it had a large impact. I personally haven't had to order any hard drawings, and since we started digging in the ground. So I think that since this was a new process for us, it took a little time for people to get on board because we had to prove the process.
Mm-hmm.
But I would say that we've probably reduced the use of paper by at least 50% on our project, which obviously translates to cost. But it also, the idea is that all this information is on here, is available to all our staff members on their terminals, on the plant room computer, or in the field. So now that they're used to it, they don't really access, even though technically we still have sets that we use, they all access the information electronically.
Okay, and the efficiency, how has that translated in terms of the overall project schedule? Are you able to build this building, in a shorter time period than you could have 10 years ago? Or?
Well, that's a great question. I mean, the reality of it is that we had a very aggressive schedule to begin with. And so our goal was to try to complete the project about 4 months ahead of our original schedule. And what this enables us to do is actually have ensure that we have, what's the word I'm looking for? Basically inform our decisions to understand that we validate what we've designed and what's designed that we can actually produce. So it's been a very good tool for that purpose, and so that allowed us to actually meet the schedule and not have bumps along the road that we haven't expected that we haven't solved yet.
And then I would also imagine that this allows you to ensure the higher quality of construction in terms of having this the detailed drawings available through a tablet, say, out in the right on the site.
Right.
How has that affected the quality of the
Exactly.
building?
I mean, one of the great things about this is that it is available in the field. So there's usually not an issue of a set of drawing that hasn't been posted, or it's out of date by a month and there's a set here and a set there and maybe someone doesn't know which one. We get these things synced every day, so they're in the field as well as in the office. Um, and the ability to use the models to create our lift drawings and to have very well planned uh, way to implement the work, make sure that we're only doing the work once and we're not redoing the work, which is where the waste is in construction for the most part. And that's what we've been able to leverage on this project, certainly.